two of the world's leading consultancies. Let's learn about how they use our products. We're gonna first talk about. Okay, this is switching to the next slide. Do I have to turn this on? Okay, good.
That does work. Just use the arrows.
The left arrow, right arrow? Yep, that's good. Yeah, so our first product is actually one of the world's leading education platforms. When years ago, we saw that education and upskilling was in general a big problem for the sector. You had YouTube videos, I guess, on one end and academic papers on the other end, and there was this big chasm of good, solid interactive learning tools that actually made it easier for people relatively new to the field to come in, learn about quantum computing, and get to a position where they could actually program a real quantum computer. Black Opal is our product. It's got more than 8,000 users. We also have a really nice enterprise offering, we'll first start with David, from Ernst & Young, Ernst & Young has been an active user of Black Opal. Let's learn about their experience. So, David, how does before we get into Black Opal and all that, how does EY look at quantum computing in general, and specifically zooming in on the education sector?
Yeah, it's a great question, and maybe I can give an overview of how we've been talking with clients and approaching them, and then talk about how that feeds into our own educational needs. So we've been engaging quantum basically from two distinct buckets, and the first one is sort of the cybersecurity defensive side, so getting enterprise organizations ready for a post-quantum future, helping them to inventory their IT systems, examine their assets, prioritize based on things like data shelf life, see what their current vulnerabilities are to quantum attacks. And we all know that they shouldn't be waiting 5 or 10 years down the line. They're at risk for sort of collect now, decrypt later attacks. So helping them to do that, to prioritize remediation, and in some cases through changing protocols for key exchange, et cetera, helping them approach remediation now. The second bucket is really in terms of quantum capability building and beginning the process of implementation. It's basically the theme of this conference that quantum is going to create a lot of value, and we are thinking of it much like machine learning or AI in the 80s and 90s, where the technology wasn't quite there yet, but people knew something was happening. People knew this was going to fundamentally change things and create value. And those that dedicated resources to educating their staff, to building talent, to building their tech stack, to identifying a roadmap when it came along, really pulled away from those that didn't. And so we're working with organizations now to identify that roadmap, to start implementing it, to start doing prototypes around things like optimization, where we're engaging with life sciences sector and supply chain and the consumer sector, getting organizations ready. Now, if I sit here and tell you that, our foremost priority is making other organizations ready, the first thing we need to do as EY and EY-Parthenon is really make our own organization ready and get people spun up there and get people spun up quickly in much the same way that we had to for machine learning 10 years ago. And Black Opal is a very sharp tool for us to help do that and help do that effectively and quickly.
Great. No, I remember as a consultant myself several years ago, when you're about to head into this new field, you may be a generalist, right? But when you're heading into a new field like quantum, you may not have ever heard of Schrodinger. You certainly need those tools. Thoughts from a Capgemini perspective?
So I think some of our experiences actually really mirror what David was saying. I think we're seeing more and more organizations interested in building some internal capability.
Yeah.
Now is the right time where it makes sense, and the ways in which we're engaging is around this sort of idea of building a quantum center of excellence within an organization. So finding enthusiastic individuals from across the business, pulling them together in a strategic way so that they can identify use cases, prioritize them, champion quantum with the organization, and connect with the wider ecosystem. So a lot of people saying, now is the right time.
Now is the right time. Absolutely, absolutely. Yeah. So, and as you looked at Black Opal, David, and you did, I guess you must have done comparisons with other offerings out there in education out there. What stood out in Black Opal, and how did you make the?
Yeah, I mean, in fact, to your point, before we engaged with you guys and had Black Opal, we have a number of other training courses, and quite frankly, they're not good, right? So they're either too simple, or it's basically a review paper, or they're slides, and you give consultants slides to thumb through after making slides, and they're not gonna learn that. Black Opal really is ed tech. It's engaging, it's fun, it sort of hits a sweet spot in terms of being approachable, but being real and being true, and it's useful for the engagement manager that needs to know just enough to be dangerous. It's useful for the computer scientist who needs to transition some of his or her skills to the quantum realm. It's useful for the STEM educated consultant who needs a bit more of the theory.
Yeah.
And we've been training people, and our goal is to double our quantum trained workforce, and the plan is to do that with Black Opal.
Yeah, and then for us, it was really the people who have gone through Black Opal tell us it's like Duolingo for quantum. So being able to speak the language of quantum really, really matters.
And I'll add, I spent 6 years getting a PhD, right? Like I should know quantum physics. But I was engaging with Black Opal. It was entertaining me. It was keeping my attention, and dare I say, I was learning things.
Good. Yeah. No, thank you. I and appreciate the support, and you guys have been a great partner. So I'm going to segue to another product that we basically released today. It's been in this beta stage so far. It's called Fire Opal. Let's see if it comes up. Yep, it's called Fire Opal. So the idea is this. Quantum hardware today as it stands is noisy, and people are often frustrated, or developers trying to get useful results out of quantum computers are often frustrated. The success probabilities are low, and the problem's even more acute as the number of qubits increases. So we've used some of the best error correction techniques in the industry, in the same spirit as what the previous talk was on KEDMA, but we've been in the business for several years now. And we released this product called Fire Opal. It's a zero config tool. It's something that you can download. Essentially, if you're an algorithm developer looking to get some useful performance on a real quantum computer, and you're suffering from low success probabilities, Fire Opal is a one line of code that you run that boosts your success probabilities almost all the way to the T1 limit of the hardware. So please go check out the Q-CTRL website. It just released today. But let's learn about the experience of one customer who's actually used it before it was released. So Sam, give us a little bit more of a backdrop of Capgemini's work in algorithmic development, number one, and number two, the specific use cases, some of the use cases that you were looking to solve, and some challenges that you encountered.
Sure. So quantum technology in general is an area we've been in for a little while, and actually have labs in sensing and communications. But following the launch of our quantum lab this year, we've really kind of accelerated our work in the computing space and in algorithmic development. And actually our narrative is around accelerating applied quantum advantage. So finding those use cases which are really going to bring value in future. And I think that works across different sort of stages. It's going after the right thing, it's framing the problem in the right way, and of course it's getting the most value out of the hardware, which I'm sure we're going to say a bit more on soon. But just to give a couple of examples, the sorts of areas. Yeah, we're just kicking off a consortium in Europe where Capgemini has a leading role, which is focusing on applications in aerospace and in energy storage. And a key focus there is actually on the near-term hardware. So getting as much value from these, the scarce and noisy resource in computing. In a completely different area, an area that's actually really close to my heart in the life sciences, because I've spent many years in drug discovery R&D. We've been looking to, we actually have been creating software to create embedding approaches, and those embedding approaches we're combining with data-driven techniques so that we can get the best from quantum simulation with experimental data for particular challenges. And actually that's something we're working at the moment with a global top 10 pharma company to make predictions of molecular reactivities, and we're seeing some really exciting results there. So across the board, lots of exciting things across industries and across applications.
Right. No, thank you. And in the same spirit of the one of the previous questions I'd asked, when you scanned the market for possible solutions that would accelerate or that would provide the type of results you were looking for, what did you find and what brought you to Black Opal?
So I think it's probably obvious, given what I said about the kind of accelerating applied quantum advantage, that there's a natural fit here, right, in terms of getting more. So having an error suppression pipeline, which you can run that will take you further on real hardware today, is obviously incredibly appealing to us. And actually, as you mentioned, I think we were lucky enough to get the chance to explore this while it was in private beta, and actually you guys gave us this kind of free choice to go after, play with anything we wanted to, and we actually chose a particular example, a subroutine that's relevant for a few problems. We looked at the inverse quantum Fourier transform, partly because, of course, it's relevant for algorithms like quantum phase estimation. So there's a link to sort of future applications in electronic structure, which I kind of hinted at in the chemistry earlier. But actually, one of our team recently joined from a postdoc in quantum verification, and he had worked on schemes where the average fidelity from a particular protocol mirrors the worst cases that you're likely to get in real world uses of that. So for example, in quantum phase estimation. So we had a really good chance to actually explore in detail and see how well it worked for us with a nice trial case before the release there. Right,
you go from trying to find a needle in a haystack experimentation to getting a little bit more deterministic, and what sort of a client impact has this had once you great, so you have a problem, maybe you do a simulation and you kind of know what the right answer is, and then you go on a real quantum computer, you do all this experimentation, then you get this boost in probability. Now, wow, this is starting to get a lot more real. You don't have to use a simulator, maybe use real. But what sort of an client impact are we talking about?
It's a fair question, right? So I guess, I mean, the sorts of increases we're talking about are quite big in the sense that we were getting process fidelities versus, just kind of running default circuits that were, more than an order of magnitude improvement, and, actually better than other approaches we were exploring. So we saw a significant uplift there in terms of those fidelities. Yeah. So it was really, really pleasing to see. But I guess in terms of that wider client impact, I think it's important to detach from that kind of specific example. That's one that we picked because it told us a lot about this. But actually, the nice thing about this is that it's circuit agnostic, right? Yeah. So it can be applied everywhere. And the fact that there is, really very little overhead, there's no parameter tuning, means that you can use it routinely, when you're working on algorithm development. And that low overhead, I think, means that it's going to have impact.
Lower user friction and all of that. Yeah. Absolutely. No, that's great. Yeah. So, David, anything to add on the topic of infidelities, fidelities, or
no? Although I would like now a trial to fire Opal, please.
Thank you. Very well put. Yeah. So I'd like to take questions, and then we'll bring it to a wrap, maybe.
You go ahead. Let's see. Questions out from the audience, and I'll run the microphone around.
By the way, our head of product, Alex Shee, and our product lead, Tom Mark, are also in the audience. So shake hands, please.
Mark Mattingly-Scott from Quantum Brilliance.
Hi.
What kind of effort did you put into putting Fire Opal together?
Yeah, so it's really a combination of methods. We have a booth. This is a combination of methods that collectively reduce noise everything from crosstalk mitigation to dynamic decoupling to gate optimization to readout error mitigation. So the whole flow is outlined. Please visit our booth. Happy to talk more.
Any other questions from the audience?
How do you price a solution like FireOpal?
Great question. This is an early release, and we are just looking to get market validation. So initially, we are making the tool available free of charge. And we are really, look, our goal is partly altruistic and partly also to build a great product. That's the reason why we are assembling one of the strongest teams, product teams in the industry. And so we're putting it out. We're understanding how people actually use it, and then we'll be able to offer a better answer a few months down the line.
And we have a question over here.
Hi, I'm David Ryan. Day 2 at Quantum Brilliance in Product in DevRel. Just a quick question as someone who used to be EY-Parthenon. Can you give some tips for how vendors and consultancies might work together in terms of collecting data for product roadmap or strategy? Is there some crosstalk, or is this really coming a lot from just yourself as the vendor?
Would you? Yeah, you want to?
Yeah,
say
I mean,
that?
I
Sure, go
can
ahead.
talk a little bit about how we engage with different vendors. It really is just sort of most of our collaborations grow out of an organic relationship. So, if you're interested in collaboration, like Let's Talk, we have a number of partners. We're looking to grow that stable of partners. Some of you may have seen in the news that EY is splitting from its audit practice, which will greatly increase the number of potential partners where we don't have to worry about things like independence. So we are very active in partnerships and looking to chase work together. So please approach me or somebody else from the team.
Okay, and one last question. Over here again.
Hi, Bob Sorensen. Nothing to do with quantum brilliance. Just a quick question. What is the characteristics of the typical end user you're going after? And I'm particularly interested in what kind of current classical IT infrastructure they already possess. Is there something you could say, oh, it's typically this or it's typically that, or is it a range of different existing capabilities when you walk into a situation?
Do you want to answer any of that, or I'm happy to?
Do you want to go first? No, I can give a sort of consultancy perspective on that question, certainly.
Really, I mean, there's a lot of talk about hybrid architectures, and really it's probably going to be a combination of processors. And a lot of guys end up starting to experiment, and they kind of look at quantum as an extension of HPC, the stuff that's already going on. And it really varies. There are certain large enterprises that make very large investments in IT infrastructure. And there isn't a set thing. For example, look, if I want to set up a data center to mine crypto, okay, so that's fairly well known. I know exactly how to set it up. But as for quantum, it's very heavily dependent on the exact use case they're trying to solve. So I don't know if you want to add any color.
Yeah, I mean, I think I was just going to add that I think many of the organizations we work with are probably sort of doing compute-intensive things already. Working on HPCs and probably kind of already know that quantum computing is likely to be a part of their future. So at the point we engage them, probably a lot of that sort of understanding or that background understanding is already there because of the nature of the business they work in.